Check. Can you hear me at the back? Raise your hands if you can hear me.
আলোচনা হচ্ছে
চেক আমি এখানে আসাতে পেরে খুব খুশি First of all, I would like to thank Dr. Sandeep right now for such a nice lecture, and very happy to be here. This is my first visit towards after coming back to India, towards the eastern part of the country, and I think this is a great place to start this conversation. Although I find it difficult to follow on after his talk, I was supposed to be telling you, get excited, we are going to the moon, we are going to Mars. He just told you not to go anywhere. So we have to save our earth first, before we get anywhere. But I think the sentiment has to be understood. I think it is a real concern. We are standing at a point wherein the data is becoming extremely visible, and we have to respect that, and we have to be cautious of how we do things as we go into the future. So in, let's say, next 20-25 minutes, I will quickly go over my mission with you. I'll share my story with you. I'm sure that you would also like to ask me some things, and since all of you are from this background, I am expecting some great questions as well. So let me finish this, I will share some things with you, and thereafter take on any questions that you may have. So, Professor was mentioning that Wing Commander Rakesh Sharma is also here. He was the first Indian astronaut to go to space. He went in 1984, and I'm sure not a lot of you would have been around when he went to space. Even I was not around. I was also born in 1985. So I did not see that happen. But we were very excited. We heard about his stories. We heard about him. But the follow-up of that mission, there was not a human space program with our country at that point of time. So we had to wait 41 years when I went again this year in June and carried a flag to the International Space Station for the first time. And what was very heartening to me, when I was interacting with the Honorable Prime Minister on the space station, for the first time ever, Hindi was being used on the International Space Station. And that was very symbolic, and it was a very proud moment for me. And I feel that it was the journey of all of us together, that we reached the orbit, and now it is our time to make it happen from our soil, our launch vehicle, and our capsule, which we will do very soon. So I think we heard quite a bit of widely explored by Dr. Sandeep himself, so I will not focus on it. But I would like to stress upon something. It is one thing to know that 100 degrees Celsius is very hot. It is totally different to touch something which is 100 degrees Celsius. That gives you some feedback. And that is what I realized when I traveled to space. We read about it, we understand it, we see it in pictures, we see it in videos. But by traveling to space, the perspective that you get is very different. It is not something that I knew. I had also prepared very, a lot for this space mission. But the experience was different. It was not what I had in mind. It was not what even I had imagined. And I think that is very important. And it highlights the fact that what Doctor was mentioning just some time back, this is the home that we have. We don't have anything else. So I have an analogy. I've written something as overview effect in the last line. Whenever you travel to space, the astronauts have something known as overview effect. And this overview effect is an umbrella term to describe the change in thought process or the psychological shift that astronauts get when they travel to space, given that they have a very unique perspective. And for me, what that was, I would probably try to put it in very short form, would be the oneness of the planet, the strong feeling that this is our home, not a particular place, not a particular region, not a particular city, not a particular country, but the entire Earth, that planet, that feels like your home. And I was finding it very hard to explain it to people as to why should it be so, why should it be so difficult, or this feeling should be strong. And then I thought about it, why do we think like it? So I have an analogy which I talk to people about. When we are kids, there are kids sitting here, school-going children. When you go to your school, your home in some ways is your identity, your parents, your brothers and sisters, your friends at home. And when you leave your school, you go to a college. To everybody in the college, your school is your identity. I've been told that there is no audio that is going to be played. So the videos will not have the audio that is going to be played. So the videos will not have the audio. But this is how the Earth looks when you are in space. This is how big it is. We don't realize of the sheer scale of these things. Although Professor was trying to mention in his talk of how big the universe is. But just looking at Earth from the outside, it is massive. It fills up your entire window. You cannot see the entire of it because we are very close. We are about 400 kilometers off the surface. But this is how it is. You see the sunrise and sunset 16 times a day and you'll never get bored. I can tell you that. Let's move on to my mission per se, and like I said, there is one thing to prepare for it and the other thing is to experience. Other thing is to experience the mission when it is happening. So we had practiced enough number of times on the simulator. I knew everything, I felt very confident. And we had also done a full test rehearsal 2 days prior to the launch, wearing the spacesuit, going up to the rocket, strapping up, everything, the entire cycle, even sitting there for the countdown, except that the rocket didn't launch. Everything was rehearsed, everything was known. So I felt very confident that, I know everything. But the data is that the engines would ignite in the practice. And that data happens when the engines ignite on the final day when you're being launched. And when those engines come on, the 9 engines of the Falcon 9 rocket, all your preparation, everything that it just flies right out of the window. You forget everything. Because it is such a powerful moment. It is such a strong event that is happening. And when I speak to kids, I describe this feeling as the same that you get when you are sitting in classrooms and appearing for exams and when you see the question paper. All the preparation that you have had, all the hard work that you have done, everything you forget. Something similar. But the data is very important. It teaches you a lot. It teaches you that you can prepare up to an extent, but then again, there is going to be a difference which you will have to navigate when the time comes, when the situation happens. And how powerful it is, I have been a fighter pilot all my life. I have flown with machines. I know how the feeling is when something ignites, when you're sitting on top of a machine and you engage the afterburner. I know that powerful feeling. I thought I knew, but the scale is different, the magnitude is different. You're going from 0 kilometers per hour to 28,500 kilometers per hour in 8.5 minutes. And that is a huge acceleration that you feel, your body feels it. And under those kind of G's that you experience, it becomes difficult to breathe. And you have to specifically train for doing that. So it was a very fascinating experience for me to just go through this exercise. And we were very excited. It was like a high-powered, I would say, a roller coaster ride. And like kids, we were also screaming. Actually, our commander had to tell us to be quiet. She couldn't hear any calls that were being sent on the ground. And then after all this dynamism, you get to space. And when you get extremely silent. When the engines cut off, the space separation happens, you are floating in microgravity, and you feel nothing. It becomes effortless, absolute silence. It's not exactly silent, but you feel the feeling is such. And space is two things. It is a lot of fun. There is no doubt about it. It is extremely fun to be there, but it is also very disorienting. The concept of space you really don't understand. We are three-dimensional beings. We call ourselves three-dimensional beings. But even if you look at the setting of this room, all of you are sitting on chairs. Everybody is standing on the floor. Nobody is hanging by the ceiling. Nobody is on the wall. Right? But in space, you can do that. That you really understand how to use the three-dimensional space. I remember my second day, I had to navigate across a module, and there was a NASA astronaut who was carrying out her experiment right in the center of the module. She had set up her entire experiment there. So there was no space for me to go. That is what I felt because I had gone from her. So I sat down and I was waiting. Then this other astronaut who comes up to me and she says that, "Shuksh, what are you doing here?" And I tell her that I need to go the other side. And she says that, "Why don't you go?" And I show her that she's in the way. And this one, she starts laughing. And she takes me by my hand, she takes me to the ceiling and tells me, "Walk here." And that is the time, your mind switches, it flips. It understands that this is how space is different. You are not restricted to one plane. You can do anything. So then we have started having days that today is the day of walking on ceilings, or today is the day of walking on starboard wall, and we would just navigate on that wall. So it was a lot of fun, but your mind has to flip. It has to understand, because you are taking some habits with you which is not applicable in the environment of microgravity. And the other concept is the microgravity itself. All of you would be aware that it is not that gravity is not there in space. There is gravity, but because you are in a free fall around Earth, that is why you don't experience gravity. You experience microgravity. And because everything is in a free fall at the same time, nothing is falling relatively. So if I was to hold this mobile in space and I let it go, it will stay here, it will not fall. But your mind doesn't know that. You got from Earth. So in the initial few days, if I had to leave something, I would search for someone and I would ask them, "Can you please hold it for me?" And I also had two first-time flyers from Poland and Hungary. And they are also thinking like me. So they would also hold it and float next to me. So while I'm doing something, all of us are floating in air, but they would be holding like this, standing like next to me. So then it doesn't fall. And this also you realize with time, how it happens that you can let go of things. Everything is going to be around you. It is not going to fall. As compared. This place. Yeah, so look at this. I'm trying to change camera lens. Both of them are. How many of you felt when I was leaving the legend falling? So this is what the mind has to get used to this concept when you get to space, that it is okay to let go of things. And after 6 or 7 days, you're really comfortable. You're leaving things, 10 different things, doing your work, collecting them back and putting them back into place. The problem happens, you come back to Earth with this mindset. And I remember first evening I was working on my laptop. I was replying to a lot of emails. A lot of emails had come, I replied, I was tired and I wanted to sleep. And out of frustration, because I had been replying to so many emails, I quickly shut it down, took it to the side and I left it. That was a very, very quick lesson learned that this will not work here on Earth. But the important aspect is that your mind is really a very powerful tool. It can make you believe things that are not necessarily happening around you. It happens both ways, when you go up and even when you come down. And it takes time for your mind or your body to understand and adjust to this new environment that is around you. The other interesting concept is the concept of weightlessness. A lot of us would be very happy if we were to weigh ourselves in microgravity. I think, we will not weigh anything. We will be light as feather because there is no weight. But there is mass. You have to be careful when you are moving things. But you can lift heaviest of objects with just one hand. And that was one key attribute because of which we could make this space station. Because it was not possible for us to send everything from ground at the same time. You could not put everything inside the modules and then launch them. They would be too heavy. So heavy equipment was launched later on, and the astronauts have assembled them while they were on orbit. And it was possible because there is no weight. You can move things around easily. But you have to be careful about the mass. And I have a video to demonstrate that. This is my commander, Dr. Peggy Whitson, who almost has 700 days in space, most experienced American astronaut as of now. And she's trying to move a heavy bag. The bag is bigger than her in a way, and it is used to transport heavy cargo. I will let you guess what is inside this bag, but you can look how careful she has to be to hold it. She can lift it, but she has to be careful of the movement. So that's almost 250 kgs of weight right there. How easily you can move it around in space. It's extremely fun. Good ways, very nice ways of explaining the concepts. How they differently. And I have one more for the kids here. When you get bored, when the astronauts get bored in space, they also have some fun time. And if you don't have a ball in space, you use a human. These are some very interesting things that you can do in space. It really changes how you think about it. Again, like I'm telling you, when you're seeing this, when you're looking at it, it is one thing. But when you get there, it really rewires your brain of thinking about things very differently. This helps a lot when you are making things for your own self. We are trying to make a space station, and this really counts. Because when you're designing something, you are thinking in terms of ground. We need to put something here because this much space we need for a person to sit or stand. And then when I look at it, I said, you don't have to worry about it. You can just float in from anywhere and slide in from any side because you are in microgravity. You're not going to be using this thing on the ground. So the experience really changes how you think about space. The body also undergoes a lot of changes. It has never seen this environment of microgravity. In the initial few days, all the blood from your leg pulls up, it goes into your head. You would see the image on the right. My head is swollen up. It is big because all the fluid has shifted to my head. Your heart slows down because it doesn't have to pump blood against gravity to your head. It will be a lot of blood otherwise. You are floating in space, but so is everything inside your stomach. So you don't feel hungry. I remember I had to force feed myself for initial first 3 to 4 days. And it was very challenging because you don't feel hungry at all. You also become taller in space. You grow in height. Because there is no load on your spine grows. And you grow tall by about 5 to 10 centimeters on an average. And every time I say this, there are some friends who are talking amongst each other and pointing to someone and you need to go to space. I was also very excited. I will gain some inches when I go to space. And the problem is that when you come back to Earth, back to your original height. Only thing you get is back pain. That too twice. Even when we don't realize it, even right now, when all of you are sitting on these chairs and people who are standing, we are using our muscles to counter the force of gravity. We get used to it, we don't feel it, but we are. And you feel it when you're coming back from space. That is why astronauts take due to other reasons as well as this, that they're not able to walk. But in microgravity, there is absolute no use of muscles to count. There is no gravity, so you're not using it. So in my 20 days of space, I lost about 5 kgs of weight, and out of which 4 kgs was muscle mass. That is how quickly the degradation happens when you're in space. And then there are psychological challenges. As it was being mentioned in Dr. Sandeep's talk as well, that you learn how to think about it, but the threat is real. You understand the risk. There are alarms going off. Most of the time they are benign, but you understand that if something goes wrong, there is not a lot of help available. You are on your own. You are in a confined workspace. You are working for long hours, isolated, cut away from everybody else. So these are all very challenging scenarios and environment wherein astronauts have to work. So you have to prepare very well. Case in example, Sunita Williams, she went there for a few weeks and she ended up staying for almost 8 months. You have to be ready for that. You have to understand, you have to accept these things. And that is what the training does to you. But we also have to solve these issues for us as a country, when we are planning long duration missions going to moon and eventually beyond. That these are challenges that we have to address. We have to navigate these challenges. How do we solve these problems? And these are complex problems to be solved. The other aspect of my mission was conducting science in space. For the first time ever, the Indian researchers got an opportunity to conduct science on the International Space Station and bring back the data. And I was very happy to be a part of it, to be a bridge amongst them and the orbit and conduct these experiments for them. And what does microgravity give you? It gives you a very unique environment. Biological processes, they become faster. Physical sciences and engineering, crystal growth becomes much easier. The water, if you spread water, it is always in the form of a bubble. The flame, if you build a fire, it is going to be in the form of a round shaped fire. So all these things give you a very unique insight into existing problems that we are facing on Earth, or challenges that we are facing in terms of experiments. But more than that, I think what are the results that we learned? What we learned was how to enable an experiment in space. That in itself is a huge challenge. What we can do something simply on ground in a lab. If you want to do the same thing in space, it's another challenge altogether. The experiment, the myogenesis experiment I did, one of the experiments that I did in space, again, you look at the problem of muscle atrophy. It was such a complex experiment that had to be done to contain the fluid in a container, how to provide nutrition to it every second day, how to keep it in the refrigerated environment. Everything has to be learned. Even the smallest of things, how to use syringe, how to use pipettes, everything you have to learn, and you have to understand how to enable it. So I think that was our biggest learning. We understand now how does it happen. How do we make it happen when we make our own space station? And after doing everything, staying there for 18 days, 19 days, it was time for us to come back home. And we were very excited for that. I actually kind of did not want to come back. I was very happy there. It was a great place to be. It is very peaceful. It has an amazing view. And you will really understand and you start enjoying the things after a few days, and then it becomes alright for you to stay there. But all that energy that I was talking about, when you go to space, when you want to come back, that has to be dissipated. You have to stop the building. It is moving at same 8 kilometers per second around the Earth. How do you stop it? You stop it through the atmosphere. And when you stop it through the atmosphere, it generates friction and heat. And that heat is not ordinary heat, it is almost as hot as sun, 4,000 degrees plus. That is the kind of temperature that is around the capsule. The entire capsule becomes a big fireball when it is decelerating in the atmosphere. I was, for one, very excited to look at this fireball. How does it look? Because you have two windows in the blue gravity. So when you look at it, it starts yellow, small flames, and then it becomes steady stream, changes color from yellow to red, orange, purple, all shades you see when it is growing. But what was very interesting for me that I had to strain my neck, lift my neck slightly to look at this fire. And after some time, I really felt a lot of strain, a lot of pain in my neck. And I thought that we must already be under 3 or 4 Gs right now. That is the kind of pain I was feeling. But again, my background, I am not unfamiliar to G loads. I have been doing this all my life. But when I got my head back and I looked at the display was reading 0.3 G. It was not even 1 G. And that is the kind of shift, that is the kind of effortlessness what I was talking about. When you try to open your eyes when you're coming back, and immediately after coming back, you can feel your eyelids, you can feel the weight of your eyelids. That is the kind of difference in effort that is there in orbit as compared to ground. And when you come back to Earth, again the same thing. As when you go to orbit, everything is new for your body. Now when you come back, the Earth becomes a new environment. And it is difficult for you to get used to this, to adapt to this. And this is a video of me 2 hours after splashdown. And immediately after splashdown, I'm sure you would have seen in the videos as I'm coming out, I was not able to walk. Even though I felt okay, I was not feeling bad. I was feeling quite okay, but I was not able to walk because my body, my mind has forgotten how much effort it takes for me to stop from falling. Every time I put a step, I will fall down because I don't know what muscles to exercise to keep me from falling. This is 2 hours after this platform. So this is how challenging it becomes. Both sides, your body has to relearn, you have to adapt. And depending on your duration of mission, you spend some time in rehabilitation, learning how to walk again and how to come back to normal life. And that is the time you get clearance from doctors to resume your normal day-to-day activities. So what is the purpose of this? This mission that I went on, I'm coming here, I'm talking to all of you, we're sitting here and we're discussing all this. We already have a roadmap of what we want to do in the field of space. We have Mission Gaganyaan, which is launching an Indian into space and bringing them back safely. And after that, we'll have the Bharatiya space station, which is making our own space station. And eventually landing on the moon by 2040. This is all laid down in the Space Policy 2023. But these are not easy tasks, or these are not easy goals. These are extremely challenging. And who will make it happen? People like you who are sitting on these chairs and benches. And this is what I'm talking about, what has been decided by the government. Parallelly, there is a huge ecosystem of the private startups who are coming up, who are trying to explore. And I would like to highlight some points, what even Professor Sandeep was mentioning in his talk. I will add on a few reasons why he said, why are we going to explore there because we need to save this. I think it works parallelly, it has to work both ways. Because when you go to space and when you try to solve problems in space, you actually end up solving problems on Earth. We don't even know. These are unintended consequences of you trying to do something extremely complex. We don't even realize that we have gifts of space travel, GPS being one, that we use every day. Now navigating and going on streets without a GPS, it is unthinkable. We can't even do it. But this all started from here. The duct tape that you use without even thinking, it's a gift of spaceflight. The Velcro that we use on all our clothes. Battery operated power tools are a gift of spaceflight again. So, very small examples I am taking, but there are many more. But it happens so that when you try to do something which is extremely difficult, what we are trying to do when we are going to space through human space missions is we are trying to create life in an environment where it should not exist. There is nothing there that says that life can exist here. We have to provide air, we have to provide water, we have to provide everything artificially. So when you try to solve such complex problems, you end up solving many more problems here on Earth. These are the unintended solutions that you get, which you did not even think of in the first place. And what will happen when we do this as a country, as a nation? You take a big problem that you want to solve. And how do you solve that problem? You have to start by targeting education. And that comes to the first level, the first pillar of the triad. Solve the education, give the right education. This education gives you the right workforce. You have skilled workforce available. And that skilled workforce goes into the industry. So this triad, it comes up together and it lifts your entire nation together, towards prosperity. Not just going to space, but also solving a lot of problems here on Earth. So some of this I've already mentioned, but to the children who are sitting here, and also what you were mentioning, that not everybody will get to be an astronaut. And that is true. Not everybody will become an astronaut. But an astronaut doesn't travel to space alone. It is not possible. When I went for my mission, there were thousands of people sitting all over the world who made that mission happen. From mission specialists to nutritionists to designers to engineers to technicians. There are so many people sitting all across the world. We travel to Japan, Germany, US, India. People are sitting and supporting this mission. That is the kind of effort it takes, and everybody is a part of this mission. You see the face, obviously, who travels to space, but all of these are required to make it happen. So even if you don't be the astronaut who goes, you still can be part of the journey. And that is what is exciting. That is what is going to happen when we develop this as we go into the future. We are going to create a lot of jobs all the fields that I have written on this slide, you can be in any discipline, and space still has space for you. That is the kind of potential that it has. And why do we do all of this? You know, the overarching dream that we have of Icsp Bharat 2047 that we have written. I feel that space exploration is really going to be a very big sector which will help us achieve this dream. And you are all going to be the fuel for this. So on this, have accountability, believe that it is your job, it is my job to take us from here to the dream of Icsp Bharat 2047. And on that note, the last thing that I have not spoken to you about is, one of the reporters I think asked me this question, repeated question, the second time, ऊपर से भारत कैसा दिखता है? How does India look from space? And rather than telling you how does it look from space, I would rather show you. Okay? So I will show to you how India looks from space. It is a night video. If you want to record, no flashes. Okay? And if you can switch off this light, it will be. And this is a night video. You will see the curvature of the earth. You know, green glow. The green glow is due to the oxygen atoms in the upper atmosphere. And you will see flashes of lights that are happening. These are essentially thunderstorms or lightning that is happening on the ground. And we will pass over India. I will point out, you know, Bangalore, Hyderabad, Pune. We will see these bright cities, and then very quickly we will cross India, and you will also see an orbital sunrise. Let's see. So the curvature you can see, the green glows due to the atmosphere, and the flashes that you see are the lightning that is happening on the ground. And this is India emerging. The brightest city that you see is Bangalore, and on top of that is Hyderabad, Pune on the left. You will see these bright flashes happening. And we have crossed India. This is Mr. And that's the sunrise. With this, I would like to conclude by saying what I said from orbit in my farewell speech. That we are really standing at a point in our nation's journey which is very exciting. We are going forward with determination and with capability, with resolve. And I feel extremely proud to be a part of it. So to all the kids and everybody who is sitting here, my message to you is this, what I gave from orbit. Sky was never the limit, not for me, not for you, not for Bharat. Jai Hind, Jai Bharat.